Hi, Statistics for Business students. We've made it to Applied Activity 3, which is halfway through your applied activities for the course. Just like the other applied activities, this one has a part 1, which focuses just on calculations, and a part 2 that focuses on communication of your skills. I'm going to give you a quick demonstration in this video that will help you to be able to start the assessment. In part 1 with your calculations, again, you're going to be working with your open data set from the City of Toronto. In this data set, you should have both a discrete and continuous variable. If you do not have both a discrete and continuous variable and you need to choose a new data set, please just email me if you want me to make sure that the data set will work for this assessment. You must work independently and you cannot use AI to do any of the work for you. For the first part of the question, you need to build a probability distribution with the possible outcomes for a discrete random variable and the probabilities for that discrete random variable. I'm going to use my apartment building registration data as an example. So first I'm going to look for a variable that's actually discrete. I have confirmed stories and confirmed units that would both be discrete random variables. Let's say I want to make a pivot table for the number of stories. Here it is, confirmed stories. And if I list all the possible options, the discrete options for confirmed stories, there's between 3 and 51. So that's actually a lot of options. To turn this into a probability distribution, instead of doing the sum of confirmed stories, I am going to look at a percentage out of the grand total that each category falls within. So for example, about 10% of the buildings have 3 stories, whereas 51 stories, only 0.36% of the buildings have that many. So this would be my probability distribution. I could copy and paste that into the assignment instructions, but because it's so long, I'd either need to add like a lot more rows in here to get it to fit, or you could put it in a whole new sheet and just tell me it's in a new labeled sheet. Alternatively, if you do not have a discrete random variable, I also wanted to show you a bit of a trick for this assessment. You can kind of treat the distribution like if you had a coin, like heads or tails. If you have a variable with only 2 options, like a yes or a no, for example, with fire alarm test records or fire pump flow or fire safety plan, for any of these with only yes and no options, you could insert a pivot table, take that variable, approve fire safety plan, and find the percent in each category for that variable. Again, I'm just going to show the values as a percent instead of as a count. There we go. So the blanks have 0%, so I'm just going to hide that. And then instead of writing yes and no, you'll assume the no's are a 1 and the yeses, no's are a 0 and the yeses are a 1, the opposite way around. And then you'll actually be able to do the calculation. So for example, if I wanted to use these values in my table, I could paste them here. I'm actually just going to paste the values only so that I don't get all the weird pivot table formulas. And this is if they have a test record for fire. This is the key X, the probability of each happening. With that, you'll then be able to find the expected value and the variance using the formulas from class. So you can use the sum product formula like we learned for the expected value, or you could actually use the definition where you have to take every single value, multiply it by the probability, and add them up. By doing that, you just extend the table. And that's the first question. Once you've made your table, then you're going to assume you have a binomial distribution. For the binomial distribution, you'll use your probability of success for one category. So let's say I say success is yes, having a fire test record, then my probability would be the 97.35%. For the number of trials, I give that to you in the question, it should be 10. And for the number of successes in that many trials, pick the last digit of your student number. So for me, that would be a 4 in my employee ID number. And then I would use these values inside of the binomial distribution. function for calculating probability. Finally, you just need to comment on if you actually think it's reasonable to use a binomial distribution for the situation you made the table for. So for that, you'll just be looking at the four conditions of the binomial distribution. You need to mention all of them for full marks. Then we're moving on to continuous distributions. We're going to focus on the normal distribution. So for the normal distribution, ideally you should choose a continuous variable. If you don't have something continuous, at least it has to have numbers for this to work. So let's say I choose the confirmed number of units. I would just take all of my data on number of units in the apartments and insert a histogram. That's step one. Then with this histogram, I'm going to copy it and place it where the histogram should go. You'll need to comment on the shape and the symmetry of your distribution. By shape, do you think it looks like a bell-shaped curve? By symmetry, is it symmetric or is it left or right skewed? Basically, you're trying to say if you think it looks like the normal distribution or not, make sure you include that in your summary. So I think this looks like the normal distribution or I think it does not. If you have a couple of possible options for discrete or continuous variables, I recommend choosing the one that the histogram looks closest to the normal distribution. Then you're going to find the mean and standard deviation, just like we did in learning outcome number 2. You'll just do the average and standard deviation of all those values to get the two values that summarize your distribution. And from that, you're going to find two z-scores using the standardized function for the min and max. That way you'll be able to comment on if those are outliers using the rule that any z-score that exceeds 3 in the positive or negative direction would be an outlier. Finally, you can pick any two values for your distribution. What I mean by any two values is if I was working with the confirmed units, like I said, I'd selected for the number of confirmed units, the least is 10 for these apartment buildings and the most is 793. So if I'm going to choose a value, I should not choose 1000. It has to be within the range of your data. And if I'm going to choose a minimum value, I should not choose 10 because again, 10 is the minimum we have. So you should pick two values within the range of your data. So maybe I'm going to pick like between 100 and 150 units or something like that because those are within the possible ranges from the data set. So if I chose 100 and 150 units, then you're going to use the normal distribution to find the probability of being between either of those two values using the mean and standard deviation from the previous question. So that's one of the between probability questions for the normal distribution from lesson 4.2. And that's the first question. That's strictly about calculations for different distributions. I just wanted to explain some of the instructions in more detail. For the second question, you're going to find a real-life application of a probability distribution in a peer-reviewed journal article. The best sources to find peer-reviewed journal articles are on Google Scholar or the Cambrian College Library databases. My best recommendation is to start by choosing a distribution you want to look for. So let's say I care about the Poisson distribution. Then I would go to just regular Google and look up like application in business for the Poisson distribution. So customer arrivals, equipment failures, customer complaints, customer staffing, quality control, resource allocation. So it gives you some ideas of what to look for. Once I have some ideas of what to look for, I might look up like customer service Poisson, because if you just search the Poisson distribution on Google Scholar, you're going to get just math-based articles that aren't really business applications. And the whole point of this question is to focus on a business application. So I just look for one that I'm interested in, probably a more recent article that's not like super old. So maybe something like this, our call center and hospital arrivals well modeled by a Poisson process. And in this article, there's likely a lot of statistical jargon. I mean, there's a lot of different like names that you might not be familiar with, and that's okay. You do not have to be familiar with all of the statistics. This one is, I think, locked behind a paywall there to view the PDF, so I'm going to try to click it back here to see if I can see the full article. There we go. So even though there's a lot of different statistical information in here and a lot of formulas, I don't expect you to understand all of those formulas. What I want you to focus on is how the author is attempting to apply a model that we learned the name of. So I would scroll down and really look at the conclusion. So they say we examined the call center and hospital arrival data and found they are consistent with a non-homogeneous Poisson process. They say that the rate should be regarded as random over different days in all cases except hospital, ED, ambulance arrivals. So if we keep going, I guess they just talk more about different sections of the paper and what they found in each section. So if you chose this article, what you would have to do is put a link for the article, put the APA citation for the article. I'll show you a really easy way to get that APA citation. On Google Scholar, just click the Cite button and copy paste it from here. This will be the citation you want to look for. And then you're going to answer a couple questions about the article. So what is the study about? That you talk about call centers and, oh, that's the wrong window. Call centers and hospital arrivals. You'd say they're trying to come up with a model for that. What kind of data is being analyzed? It seems like they're going to be looking at time, how much time it takes between maybe a call being put in for needing an ambulance and arriving at the hospital. I'd have to actually read the full article to know if that's exactly what they're looking at the time of. But from my quick scan of it, it's something about timing, which fits the Poisson model. So you'd say the Poisson model is used because Poissons are used to model average time it takes for events. Then how is the distribution used? So you'd say why it's an appropriate fit, talking more about the times that they're looking at. What did they find? So at the end, they say that a Poisson process does fit, and they talk about the rate parameter you have to assume at the very end in the conclusion. Rate should be regarded as random over different days. And then finally, does this mean anything in real life? Like, could people actually use this in call centers to improve their time or within the hospital? So see if there's anything in the study that said it could be used in real life. And there's 2 marks on basically all of the explanations, except for the first couple, like just naming the distribution and it being counted or measured for the type of data, meaning is it discrete or continuous? And that's one example for the Poisson distribution. There'd be tons and tons of examples of articles for the normal distribution, for the binomial distribution. So those are the ones that I would normally recommend starting with. Also, if you thought, whoa, this article has a lot of math in it, it's not really making sense, you don't have to choose one this complex. You could look for one that you think's a bit easier of a read and easier for you to get through to find those pieces of information you need to answer the questions. But in my questions, I am not looking for math. I'm looking for just quick statement on how the authors get to some kind of useful conclusion using the math. You don't have to summarize the math. You don't have to understand the math. Just get to that ultimate conclusion of what they were able to find. This part on the journal article is out of 12 marks. The calculation part is out of 25 marks for a total of 37 marks on Applied Activity 3. If you have any questions about the applied activity, please reach out. Good luck on the assessment, and I'll talk to you soon.